morning everyone. Myself Lavanya, I am working as Assistant Professor in the Department of ECE, MIT Mysore. And my today's topic is Embedded Systems. So if you just hear the name Embedded Systems, so you can see that we have two words which are involved here. So one is embedded and another one is system. So what is embedded? So embedded means something which is hidden. For example, if we purchase any of an electronic component, so we just see the outer look. We doesn't know, so what are the things which are present inside. So that means, for example, if we consider your smart watch, or it could be with respect to your smartphone. So we can just see the outer surface of your smart watch, or it could be with respect to your smartphone. But we doesn't know what are the components which constitute that smartphone. So that is what this topic is going to tell us, what are the things which are present with respect to that embedded. That means the things which are completely hidden. Then we have one more word called system. So each and every system is going to perform its function according to a set of rules. For example, if we consider a simple analog watch, so it is going to show you the time after an hour, and it also shows you the working of or the completion of a minute. So how it is going to show the time? So it is going to have some specific rules. So that means to complete 1 hour, so how it has to process. That means how the needle has to move, and when it has to complete 1 hour, or after how many seconds it has to complete 1 minute. So every embedded system is going to perform some specific function according to a set of rules. So let us define what is an embedded system. So before we discuss the further topics under the section embedded system, so let us know first what is the definition of an embedded system. So that is, what are the components which are present, main components which are present, and after coming to know what exactly defines your embedded system, so next we are going to study about embedded system versus general computing system. That means how your embedded system is different from other general computing systems which are available. Like we have numerous computing system. For example, if you have your desktop, your laptops, your washing machine, so like digital camera. So even though we have numerous computing system, so how your embedded system is different from all those computing systems which are available in nature. Then once you come to know how your embedded system is different, so then is classification of embedded system. That means on what criteria you are going to classify your embedded system. That means if you want to buy a new smartphone, so you are going to first check what are the criteria, like what is its memory, and what is its camera resolution, and what is the size of your camera, and what should be its processing speed. So those are the things what you are going to check. So here also, whenever we are going to choose any of your embedded system, so we are going to choose our embedded system depending upon some criteria, so where we are going to discuss about that under the classification of embedded systems. Then we have the application areas. So in what are the major, so we are not going to discuss the general application areas, but we are going to discuss the main or the major application areas where we are going to use our embedded system. So like your embedded system has spreaded over a variety of applications. For example, it starts from your home and it ends with respect to your office, as well as with respect to your automobile engineering, so with respect to aerospace. So we have numerous vast application areas of embedded system, and let us discuss all those things under this topic in our further classes. Then we have next is elements of an embedded system. So we are talking about embedded system. So we should know what should be present with respect to your embedded system. Like what should be its input, what should be its output, what should be its core. That means what is the main thing which constitutes your embedded system. Other than your input and output, what are the rest of the elements which should be present in your embedded system to be called as an embedded system. Then after that, so we have two more topics where we have microprocessor and microcontroller. So we know that we can either use these two as our processing chip, or we could call as the heart of our system. So for any working of your embedded system, we can either choose a microprocessor or a microcontroller. So on what basis you are going to choose your system, under processor or a controller? So before choosing what we need to have, whether to have a processor or a microcontroller, so we should know what are the basic differences we have with respect to a processor as well as a controller. So we are going to study what are the differences under this topic, and then we have RISC versus CISC. So RISC in the sense it is reduced instruction set computing, and CISC means it is complex instruction set computing. That means reduced instruction set computing in the sense, so we are having a reduced number of instructions for processing or for movement of your data or for processing of our data. In the case of CISC, we have complex instruction set computing in the sense we have more number of instructions for processing or for movement of our data in and out of your input device, output device, or to your memory or to registers, wherever we want to move your data. So that is depending upon what type of architecture. So we want to choose whether we need to go for a RISC architecture or we want to use the CISC architecture. So depending upon this also we are going to choose our embedded system. So these are the topics what we are going to cover in this today's session. So now let us know what is the definition for an embedded system is. So embedded system is nothing but it is a system so which consists of hardware and it consists of a software, and the most important component with respect to your embedded system is a mechanical device. So along with hardware plus the software, we also require a mechanical device which makes unique to identify why it is called as an embedded system. So where it is a general computing system which constitutes an hardware, a software and a mechanical device which can be used for a variety of applications. For example, if we consider a washing machine. So in case of our washing machine, so we have hardware and we have software and a mechanical device. So now what constitutes the hardware of your washing machine? So where you can see in the hardware part, so we have the switches, that is nothing but the push buttons. Then we have the display panel. Then we have water inlet pipe. And an outlet pipe to drain out the water. And we have many other hardware components which are present with respect to your washing machine. So, where I have listed a few here. Then under software, so we have programmed, that means we have either a microprocessor or a microcontroller for the controlling action of your push button, your switches, whether you want to rinse the cloth, or whether you want to wash the cloths, or whether you want to make the cloths to dry. So this is how you have hardware as well as software with respect to your washing machine. So only the hardware as well as software is not enough. Along with this, you also need a motor. That means inside your washing machine we have a turbine where it is going to rotate. So the rotating action of the turbine is done with respect to a mechanical device where we have a motor. So where depending upon the motion of this motor, so your cloths will be washed, or it will be rinsed, or it will be put into dry, as well as if you want to drain the water, pump the water out. So that is done with the help of the mechanical device. So these are the things what are the main, or these are the things, or we can say the main components which present with respect to your washing machine. So that means when you just see the washing machine, you could just see the outer part, that is the buttons on top of your washing machine, as well as the wash, that is the tub like structure what you see with respect to a washing machine. But we doesn't know what is the software which is programmed to rotate your mechanical device, that is motor. And also here it is called as an embedded system because it is going to perform only a specific application. So specific application in the sense, so it is going to perform only a single operation, or it is designed only to perform a single application. I cannot ask my washing machine to wash my dishes. So it is going to wash, and it is designed only to perform the washing of the cloths. So we call it as a washing machine. So similarly, if you go for the dishwasher, so it's not going to wash the cloths. So that's why here your embedded system is unique in its application, and for what application you have designed, it is going to perform only that particular operation. So similarly, if you just go for your air conditioning system, that is AC. So where in our home, if you have an AC, so you might have seen, so the hardware of your AC, so where the box, the outer box, so again your AC also consists of hardware, software, okay. So where in the case of hardware, so what it consists is, it consists of input device like sensors. So where it is going to have moisture sensor, so it is going to sense the moisture in the surrounding area inside your room, and it is going to turn, that means it is going to control the room temperature depending upon the room temperature. So you can have, or you can make your temperature low or high. So how your AC is going to come to know whether the temperature is high or low. That is depending upon the sensors which are present inside your AC. So that means it consists of both hardware as well as software. So whenever your air conditioning system is going to sense the input, how that input has to be processed and known to your system to control the temperature. So that is being done with respect to your software. So that's why here, so every system, every embedded system, it consists of mainly your hardware, software as well as any mechanical component. Okay. So not every embedded system should consist of a mechanical device, but whenever we want to have a rotating action or a pumping action to be taken place in almost all those applications, so we are going to have this mechanical device which will be present with respect to your embedded system. So now let us know, so what are the differences we have with respect to a general purpose computing system as well as an embedded system. So that means, as I told previously, so we have numerous computing systems, but we cannot say all computing system as an embedded system. So we have some differences how we are going to distinguish many of the computing systems which are available with respect to a given embedded system. So we have listed some criteria here. So where we have 7 criteria which has to be satisfied with respect to an embedded system. The first most criteria is contents. That means what are the things which are present with respect to a general purpose computing system. So of course, so here it consists of hardware, then software and a general purpose operating system. That means you have a hardware, you have a software as well as a general purpose operating system which you can use it for a variety of applications. Then coming to an embedded system, so it consists of again an hardware, a software plus a mechanical device, a mechanical component, plus it also consists of an operating system, or in some cases it might not have an operating system. It is not mandatory that your embedded system should consist of an operating system. But in every general purpose computing system, so you will be having a general purpose operating system. So now coming to your OS. So what should be your operating system? So as we have defined in the content part, so it is having a general purpose operating system where your operating system can be programmed depending on the program for a variety of applications. But in the case of embedded system, so you cannot reprogram it, or so as we told that it is not mandatory that it should consist of an operating system to perform its operation. Next we have alterations, the third criteria. Alterations in the sense, so you can make any changes with respect to your hardware as well as you can reprogram your software in the case of your general purpose computing system, and you can use it for other application. Like if you have designed your system for performing an operation, so the same can be reframed. That means you can change its hardware and you can reprogram the software and you can use it for other application. That means alterations can be done with respect to your hardware as well as your software in the case of general purpose computing system. But in the case of your embedded system, you cannot alter, you cannot change your hardware and software. That means no changes can be made with respect to your hardware and software because you have designed your embedded system to perform only a specific application, or you are going to make your embedded system to perform a single application, like it is manufactured, or it can be used only for performing washing of clothes if you have implemented or if you have designed your system for working as a washing machine. So, but in case of general purpose computing system, you can make changes with respect to your hardware as well as your software. Next is the key factor. So, key factor in the sense, so how fast your general purpose computing system is going to work. So, that means its speed, its accuracy. So, all this comes into matter with respect to your key factor. Then we have power consumption. So, power consumption in the case of general purpose computing is more than in the case of your embedded system. So, where in the case of embedded system it is less, because in the case of general purpose computing system, so you have to have interfacing of the devices externally, but in the case of embedded system, so all the components will be, it will be already available within your processor. So, you need not interface it externally. So, that is why the power consumption requirement with respect to your embedded system is less as compared to your general purpose computing system. Next we have the response time. So, the response time here is more critical. So, here it is less. So, critical in the sense, so the system should respond instantly. That means when you give some input, it should respond to the corresponding input and it should produce the output with no delay. So, in the case of general purpose computing system, so it is going to have delay, that means it has more delay with respect to completing a task. So, but in the case of embedded system, so it is less critical, that means it is going to perform its operation within the deadline. Then we have execution. Execution here it is not deterministic. So, deterministic, and here it is deterministic. So, that means in the case of execution, so it is not, there are chances that it is going to, your system might not work properly in the case of your general purpose computing system. But in the case of embedded system, your system has to work properly. That means it has to show or it has to complete its task properly. So, that is what we call it as deterministic and not deterministic. So, in the case of general purpose computing system, so we can, it is not, we can say that it is soft real time bound, and in the case of your embedded system it is hard real time bound. So, hard real time bound means it is determined, that means it has to execute its operation within the specified time, but here it does not matter that. So, there are chances that it might not show you the correct result within the allotted time interval, or I can say that it is not determined with respect to its operation. So, that means there are chances that it gets failed, your system might get failed in between, but in case of embedded system it is not so, it is going to perform its operation within the specified time interval. So, these are the criteria on which we are going to distinguish your embedded system with respect to your general computing system. Its contents, operating system, alterations, key factor. So, in the key factor, as I told, its performance, like what is its speed, its accuracy level. So, performance here it is faster, So these are the criteria on which we are going to classify your general purpose computing system with respect to your embedded system. After knowing the differences with respect to a general purpose computing system and embedded system, so now let us classify your embedded system. As I told, so we have some criteria on which we are going to classify your embedded system. So where we have the 4 criteria here. So the first one is based on the generation, like so to which generation your embedded system belongs to. So where we are going to study about different generations here. So where we have first, second, third and fourth. So in different generations, what type of processor and controller we are going to use, and what is the type of application which can be used with respect to these generations. And at present we also have the 5th generation also. So the smartphones what we are using presently, it works with respect to your 5th generation. Next is based on complexity and performance. Complexity in the sense how complex your embedded system, whether it is user friendly or it is very complex to use, and what about its performance, whether it is going to perform at a very faster rate, whether its accuracy is good. 3 classifications under this, that is we have a small scale, medium scale and large scale. So we'll discuss about this complexity and performance in the next class. Then on deterministic behavior, as I told, so on deterministic behavior, so we are going to classify whether your embedded system is hard real time or whether it is soft real time. That means whenever it is going to perform its operation, whether it is going to perform within the allotted time or it is going to delay or it is going to miss its operation. So that we are going to check. Then on triggering. Triggering in the sense, whenever you want to turn on some devices, we need to apply some external force or external voltage or current. So let us see, so what type of triggering we want for triggering our embedded system or for making our embedded system to perform its operation. Thank you.